So this is the basic syntax of creating a stored procedure: create or replace procedure followed by a name. I'm not putting a name yet because I want to first explain to you the purpose of this example. We're going to then create a table, and then we're going to come back to this example and complete it. Before I move forward with this idea, now let's look at what exactly do we mean by the word transaction. Transaction works on one principle, and that is the series of steps are considered one single unit. If any unit fails, the whole transaction fails. That's what a transaction is. It's a series of steps that is considered to be one single unit. Now, for example, if you swipe your credit card and one of the many steps failed, the entire transaction fails. Okay? Otherwise, what's going to happen? Somebody will have your money, but you will not going to get your goods. Okay? So in order to avoid those kind of things, we create transactions. So transactions work on the principle of atomicity, consistency, isolation, and durability. In short, we call it ACID.
Sure, there was never no drug in the program.
Just like there are legal drugs, we call them Walgreens. Now, what do we mean by atomicity? Atomicity comes from the word atom. Atom, which means that it has to be considered as a single unit of work. It doesn't matter how complex it is, entire transaction is a single unit of work. You can't further decompose it and say, well, you know, partially this will work and partially that will work. No, everything has to work or nothing works. Consistency is like balancing an equation. So if something happens, as a result of that, something else should also happen. If money gets moved from one account, it should be received by the other account. Isolation, each transaction works independently of the other transactions. For example, at the same time, on the same bank network, multiple transactions will going to take place. But each transaction will going to be treated independent of the other transaction. Until and unless those transactions are dependent transactions, then once again it becomes one transaction. Durability. Durability is, in case of failure, there should be a backup recovery mechanism available. Or rollback process available. Or save point process available. So save point allows you to go to a certain point and then restart from that point rather than having to start everything from the beginning. So as we start going through more complex transactions, we start putting some flags all the way through, and then we can roll back to those flags. So what we're going to do is, we will going to create a table in which we will going to record some atomicity properties of a stored procedure. Because generally speaking, stored procedures are used that you call them once, it does series of steps, which could include multiple read-writes, and then it sends you one response back. So now those multiple read-writes, if they must be according to the ACID properties, then they must run in atomicity, consistency, isolation, durability. So we need to make sure our stored procedure is in a state where either nothing works or everything works. By default, that's not the case. So we're going to be creating this table. We're going to try the example with non-atomic, and then we're going to change it to an atomic. So the first thing is we're going to be creating a table. Create table atomic state test. Type atomic varchar 40. Message varchar 50. So create this simple table with two fields, where the first one is type atomic, where we're going to either report atomic or not atomic, means whether everything is going to be treated as a transaction or not. We're going to have a stored procedure, create or replace procedure. We're going to call this one not atomic procedure. Now, when we begin our block, we will going to say that this block is non-atomic. What does that mean? That means all the SQL statements are independent of each other. Whichever one goes through. Whichever one fail, they're the only one that fail, and everything after that will fail. So it's like an interpreter. That's how it's going to work. Now, we're going to have an insert statement. Insert into atomic state test. Values. Not atomic. Before error. Now we will going to also learn how you can raise an error yourself in the middle of the program. We'll actually do that. It's like in Java, you call an exception. That's basically what you do here. So raise an error. We're going to raise an error so that everything after that will going to fail. In order for us to raise an error, we'll signal a state, SQL state, and we're going to pass an error code of 7,000, which is an error code of 70,000. Just an error code. And now let me try to make another insert here after the error. Insert into atomics, not atomic after error. Once the compilation goes through successfully, then please make a call to this procedure.